Hey everyone, today we're settling the debate, Vllm versus Triton Inference Server. If you're deploying large language models in production, this comparison will save you weeks of testing. Hit that subscribe button and let's dive in. Vllm is a specialized LLM inference engine from UC Berkeley, designed exclusively for language models. Its killer feature? PagedAttention, think of it as virtual memory for AI, dramatically cutting GPU memory waste while serving more users simultaneously. Triton is NVIDIA's enterprise-grade, multi-framework inference server. It's the Swiss Army knife of model deployment, handles vision models, speech recognition, LLMs, even custom Python code, built for production environments that need rock-solid reliability. Performance architecture. Here's where it gets interesting. Vllm achieves 2.2 thousand tokens per second per GPU using continuous batching. It streams requests in and out without waiting for batches to complete. This means dramatically lower latency for chat applications. Triton, when paired with TensorRT-LLM backend, matches Vllm's raw speed in MLPerf benchmarks, but there's overhead. Recent tests show Triton adds 20–30% latency at high query rates due to request packaging. However, Triton's dynamic batching excels for non-generative workloads like embeddings or classification. Memory efficiency. Vllm's PagedAttention reduces memory fragmentation by up to 4x compared to traditional methods. In practice, this means serving 2–3x more concurrent users on the same hardware. For a 70B parameter model, that's the difference between 100 and 300 simultaneous sessions. Triton offers solid memory management but lacks the LLM-specific optimizations. Where it shines is managing multiple different models efficiently on shared GPUs. Deployment complexity. Vllm wins on simplicity. One command, Vllm serve model name, and you have an OpenAI compatible API running. Setup takes literally 5 minutes. Triton requires model configuration files, repository structure, and understanding of backends. Initial setup takes hours, but you gain enterprise features, model versioning, ensemble pipelines that chain multiple models, and unified observability across your entire ML stack. Real-world use cases. If you're building a chatbot, RAG system, or coding assistant pure LLM workload, Vllm is objectively faster to deploy and typically more cost-effective. The V1 engine released in 2025 brought 1.7x speedup and zero overhead prefix caching. Running mixed workloads, image generation plus text, or speech-to-text feeding into LLMs, Triton is your answer. You can even run Vllm as a backend inside Triton, getting PagedAttention performance with Triton's orchestration. Hardware support. Both support NVIDIA GPUs. Vllm recently expanded to AMD, Intel, and even Apple Silicon. Triton supports broader hardware including AWS Inferentia and runs on x86, ARM CPUs. Framework flexibility. Vllm focuses on transformer-based LLMs from Hugging Face. That's it. One thing done extremely well. Triton supports TensorFlow, PyTorch, ONX, TensorRT, custom backends, basically everything. If your production stack has diverse models, Triton prevents vendor lock-in. Bottom line, for pure LLMs serving chatbots, agents, code generation, Vllm delivers better throughput, simpler deployment, and lower costs. It's the specialist that dominates its niche. For enterprise AI platforms with multiple model types, or when you need advanced features like model ensembles and centralized governance, Triton is the professional choice. And remember, they're not mutually exclusive. Many teams run Vllm for LLMs and Triton for everything else, or use Vllm as a Triton backend. Choose based on your workload, not hype. Links to both projects in the description. Subscribe for more AI infrastructure breakdowns. See you next time.